Welcome to the Structural Engineering Podcast. My name is Max.
And I'm Zach.
And this episode, this isn't a real episode. I'm not sure what this is. This is an in-between episode. We talk with Tim Uhler over at Awesome Framers. You can find Tim on Instagram. Tim is a master framer. We learned a lot from him, and we hopped on Instagram Live with him and took questions from contractors, wood framers, and GCs. General engineering questions.
Yeah, and I think it was pretty cool kind of getting to hear the questions they have, which I would never have guessed or even thought about. So it was pretty awesome to see those questions and to get to discuss them.
Yeah, there were some tough ones in there, and then hopefully we'll get to do this again. This is sort of part one. We talked to Tim for 2 hours, so I edited down the first hour, and that's what you got here. And then we'll get the second hour up sometime.
All right, let's head into it.
Hit it!
I'm really excited about this. So the Structural Engineers Podcast, I reached out to those guys, Zach and Max. I think I just met them for the first time on a Skype call here in the last 15 minutes. So I'm really excited about this because I know you guys, like me, have a ton of questions about engineering, or just we don't understand a lot of this stuff, and maybe nobody ever taught us. And maybe we can't get it here. Okay, good. Can't hear the fan. And maybe we can't necessarily call our engineer and ask him questions, or maybe we can. But anyway, we've got these two guys on here.
Oh.
Hey, that's not bad. It's just that creepy guy looking over your shoulder.
Hey, that's what you do.
That's awesome.
I'm Zach, again, with the Structural Engineering Podcast. Both Max and I produce it. We started a few years ago and have had a lot of fun, going through the steps to do that. My background is mostly based in high seismic design with wood and steel, similar to Max. We met each other here in Colorado, and now Max lives in Utah, and I'm still out here in Colorado.
Awesome. So I think, Max, are you guys seismic zone D too?
Yeah, D. We're seismic D.
Okay, I thought the first time we tried zip bar sheeting, we had it delivered to us, and then right before we were going to use it, Huber called and said, "Oh, by the way, we had a builder in Salt Lake City that says it hadn't been certified yet for seismic zone D." So we had to wait on that. They had to do testing because you're nailing through the half-inch panel plus the 1-inch foam. And so they had to do testing on whether the nail would bend. I forget what that's called. It's not called slippage, is it? When the shear panel's offset from the face of the stud?
Yeah, it's just more of a shear action where it's going to bend. We got asked that the other day. There's a lot of products out there similar to that zip system where there is, some sort of foam on there, and there's some interesting testing on it. I think the zip system has been vetted, but there's other companies out there that are doing it that doesn't sound as like they've done the right testing. But
yeah, I could see that. I know our engineer, when we first showed it, he was a little concerned, and his specific comment to me was, "Can you provide me their engineer so that I can give him a phone call?"
Right. Yeah.
And Terry he finds things in the somehow he can dig up the report much more quickly than I have figured out how to do it, and he really gets into the weeds on it.
Oh yeah, that's the one of the tricks we got. We can find the reports quick.
Is that his own class in school? Is just how to find the report?
Oh yeah.
So we've got a few questions. I don't know. There's probably 10 questions that came in from people overnight. One guy wanted to know why he had to cut the horizontal rebar 4 inches back from control joints and retaining walls. So who wants to tackle that one?
This is starting with I don't know if it's a hard one or a weird one. Why'd you do it, Zach?
Sure, no problem. So, yeah, you definitely don't need to cut it back 4 inches. That's probably something that I would say is maybe more of an old school thing. You typically only bring it back, depending on kind of where it's ending, 2 to 3 inches from the end of your wall, and that would be all that's required. There might be something where it's easier to construct or to put together. But I don't know of any reason in the code where 4 inches is specified as to cut your back your longitudinal bars.
Yeah,
okay.
I mean, they might be looking at what cover they may expect, and 4 inches is not an amount of cover that is required by anybody. But a lot of these things are kind of hand-me-down. We were talking before we went live here that there's so many things in construction and in engineering that the first principal started doing and taught the next guy to do, and it's in your typical details, and maybe they have a good reason. Something came up once, but I have never held bar back 4 inches, and I don't think there's a code requirement to do so.
Okay. I'm going to try to keep an eye on these questions that come in too. Okay, this one I think is humorous. Pins3434 says, how do you guys get so good at over-engineering?
So much school for that, yeah, and then all the continuing ed in over-engineering specifically.
Yeah,
really,
it's...
really nail it home.
Is it like an online webinar that you pay for once a year that's like how to over-engineer compared to last year?
Yeah, and there's this glitch in all of our calculators that makes everything twice as big.
Nice.
If anyone wants to learn more about over-engineering, just listen to our podcast. That's all we talk about.
Nice plug. So actually, that is a good question, because that's one of the things that I've said it before. I know a lot of people say it out in the field. They're just like, this thing's over-engineered. What would be your answer to that? I mean, obviously I don't know. Most of us don't. We're not engineers. So how do you guys tactfully kind of set us straight?
Usually, because we get that all the time, or I've done this for 30 years. That's the biggest one. I've done this for 30 years. I've never seen this. And it's okay. So that's usually where we got to start the conversation of walking them through why. It's just educating the guys in the field of why things are changing. And it's not that we're trying to make anything more difficult. It's just the code's changing. We're not at all usually ever trying to over-engineer things. We design to a certain type of, there's a capacity for a system, and we have some type of demand. And that demand capacity ratio, or, we're looking at maybe 90% stress of items. We're not going over and beyond. And the big one that gets asked a lot is in high seismic regions, where you are, or Max is in Utah. And, people are like, what is going on? And every time we have a new code cycle, the seismic code specifically gets more and more stringent. And after every earthquake that we have in the United States, and sometimes internationally, the better our code gets, because we have better data, and also it comes down to more testing in the laboratory as well. So it's usually a conversation, and then we kind of walk through it. And whoever we're talking to goes, oh, yeah, you're right. I'm just teasing with you, But that gets brought up a lot. So
yeah.
This is sort of like ammo for you guys. We will also sometimes make decisions that seem to us as notch framers that it will be more efficient for you guys to maybe have less connectors that are stronger, and then you could just do the same thing over and over again, or something like that, where it's like, we know we need a number 5 bar for 10 feet on this footing, but let's just, run it for all 25 feet or something. We don't always make the right call on that, absolutely, because we don't know, and we actually don't know that much about cost. I wish I did, that this is something that was discussed a little more, but we have a lot of catalogs. There's no dollar value in any of those, right?
Interesting. That's good to know. Let me get this out of the way too. So are you guys paid or sponsored by Simpson Strong Tie or any of the hardware companies?
Man, we wish. If anyone here is listening from Simpson, send us some money.
Nice. Okay, so no commission the more A35s you throw at a house or hold downs.
Not at all.
Okay, here's a good question. How much strength is adding strapping to a house? Like the East Coast, they'll strap the undersides of the second floor ceilings or undersides of the rafters.
Oh, absolutely. Yeah. So you're talking like the rafters to the studs, or to the...
No, they're just... It's basically, if I'm understanding his question correctly, on the East Coast, a lot of times to kind of flatten out ceilings for plaster or drywall back in the day, they'll run like 1x4, 1x3 space just underneath, nailed to the underside of the joists. Okay. And a lot of guys swear that it helps them flatten out ceilings and it provides a chase for wires. So that kind of thing.
Huh.
It's a very East Coast thing.
So it's like a lath.
Basically, yeah. It's like the old days when we used to skip sheet roofs for shingles instead of structural sheathing.
Yeah, so it probably stiffens up the member a little bit. So it does provide maybe a little bit stiffer of a system is what I would imagine. I would say structurally, if your engineer's not specifying it, it's probably going to add a little bit to it, but we don't anticipate it. It would be like, on a house or any type of wood building, we have wood shear walls that are taking the lateral load. Well, we also have gypsum on the inside of the wall. Well, that also can take some of that lateral load, but we don't anticipate it. So traditionally, there's a little extra, and sometimes with that, with different systems being added in there, a little bit more rigidity to the system than we anticipate, which isn't necessarily bad. So I would assume that it's probably something similar to that is happening.
It won't add very much, especially on the bottom. So if you look at bracing of a beam, which will often specify, if you have some long span beam, we'll say you need to have this bracing, you'll have this force at some spacing. On the underside of the beam, you need to brace the compression flange, basically. So if you look at a beam and bending, it's really the top that needs to be braced. So this kind of lap system is hitting on the bottom. The only thing it would really strengthen is your uplift forces. So if you have a truss, it's not going to do very much. But if you're just a joist ceiling, it will add a little bit of strength for uplift if you're at high wind uplift. But I mean, so will your plaster. So
Yeah.
Okay. Yeah. Good to know. It can be kind of a rabid debate. I've seen it over the years in the forum where it's mostly certain parts of New England, and then west of the Mississippi, almost nobody knows what's being talked about unless they've looked at the old magazines, but hotly debated at times. How about, I'm not sure the specific question on the importance of fastener selection and fastener schedule with wood member repair. So I'm not sure exactly what that question, what I'm going to guess is like if our engineer told me that I needed to sister something on with, let's say it's a 3 1/4 by 1/4/8 nail, but all I have is a 3-inch 1/3/1 nail. You know, how important is it? I mean, I know the answer. We got to do it the way the engineer spec'd it. You know, otherwise we assume the liability. But actually, structurally speaking, how much of a difference is there? Like, let's say he spec'd 12 nails, and I'm like, okay, I have a slightly smaller nail. I'll go ahead and put in 15. Do I have to wake up in the middle of the night worrying about that?
Oh man. There's definitely an equivalent amount of nails. I think that is definitely something. If you're just looking at nails, now if you're looking at nails versus screws, there's a lot of difference. But just looking at nails, I'd say there is some fashion that you could take a smaller nail, as long as you're still getting the embedment length that you need, which could be a problem, and add more of them to get that to work. It's best to ask the question. I'm not sure about Max. I don't mind the question being asked. If it's something about 12 nails or 15 nails, usually it's like, come on, would you mind just getting the right nails? Like,
yeah,
the interaction, takes time and money from both of us, everyone in the process. So something like that.
I am always game for phone calls on stuff like that. I mean, in this example, we have a table with these values, so it's so easy. I don't have to know what my original calcs look like exactly. I can just do 13 times the one nail, and then what is that, 15 of the other. There are definitely a lot of cases where you can easily go down a little bit. It's like, we don't know what you have on site, so we guess like what we think is the most common nail. Yeah, so that's such an easy discussion, quick call, like if you have your engineer's number and just figure something out.
Is that a common thing for you guys to get a call from like the foreman or site supervisor?
I'd say this. I think in the time I did residential, it was less common. I do much more commercial now, and they're very formal with RFI processes. But on more informal things, definitely I make sure that the whatever they are, the project engineer who's ever on site has my number so they can hit.
Okay.
Yeah, I find us being fairly collaborative on that. A lot of times, just because we're showing it one way, that's in our head the best way to build it. But when you go to the craftsmen in the field of all different, disciplines, they're the ones building it. They know the best efficiencies for their crew. I'm typically more than open to have that discussion and try to work through things where, they can save schedule, save money, save time. And at the end of the day, the owner is getting a project quicker and for less money. And so that's always a benefit. So I have a question for you, Tim.
Yes.
What, in your opinion, what makes a good structural engineer?
Yeah, good question. So the engineer that we work with, Terry, we've worked with him since I think 2006. And he's probably in his early 70s at this point. He's retired, but he still does our work because we don't have that much work. And what I love about him is that he asks me, how is it that you guys want to frame this? And what's nice now with Instagram is a lot of our plans were prescriptive, and we worked really hard to make sure they were prescriptive. But we've got one particular municipality that has been just a nightmare to deal with. And so we're just having Terry engineer the whole thing. And that way, when they tell me the answer is no, he can say the answer is yes, and we can submit a letter. And it's I think it's a little more expensive, but if we build the same plan multiple times, we'll kind of make that up. And so I can send him pictures, time lapse of this is how we built the house the last 3 times. Can you make this calc out? So that works out really well. The other engineer that we've worked with, he was pretty easy to deal with. He just threw a whole lot more hardware at things.
Okay.
Yeah.
But he didn't require anything too crazy. He does a lot of the work in our area. So, and then on volunteer projects, the engineers have been real good for us to deal with over the phone or by email, and we really did track the RFIs so that it was and then at the end of the project, there could be an as-built for any changes made along the way.
Right.
I think that if it was up to me as a framer, I'm in a unique circumstance because we are the general contractor, so we just self-perform the framing.
Okay.
So it's easier for us to give a bunch of questions on the foundation requirements, and for us, mostly it's lateral. Gravity loads are pretty straightforward. We have a forklift, so however big a beam he wants to specify, we can put it in pretty easily. So it's just the lateral stuff. I guess from an engineer, the short answer, I've already rambled, is just communication. So like let's say you had a question on with this detail or that detail, which would be easier to build in the field, ask away. We would love to answer that.
Collaboration and communication is what I pulled from that. And I feel like at the end of the day, that's typically the approach Max and I both take on, construction. I don't know. I learned so much when I call the contractor, and they walk me through maybe how they've done it in the past, or I think we'll get to this question eventually, but how engineers do different things. Every contractor set up to do it a little bit differently. They have different tools. And we find at the end of the day, if we can meet their system with meeting the engineering requirements, I mean, it's a win-win.
Yeah. So there's a question in the comments that I think a lot of us in the field do wonder. How come you can drill such a giant hole in an I-joist and you can't in a 2x12?
Max?
Oh yeah, I'm all over it. Okay. There's a couple differences in an I-joist and a normal framing. And one of the big ones is that an I-joist is being engineered lumber. It is very uniform. And if you're putting a hole into a 2x12, there's knots in there. And there's basically a lot of stats that, is way beyond us. We are not dealing with this. But when we're looking at the strength of a piece of wood, the strength that we see is way less than it probably will be. Because if there's a bunch of knots in a row, then our strength is way, way less. And it's kind of the same thing with a 2x12. If you happen to have a knot right below, and then you put a hole right above that, it might seem like you're only missing 3.5, but really, you're missing this whole portion below. And that, it's obviously not going to happen very many times, but it can't even happen once, or else it'll fail. So we're dealing with that. And then the other thing with I-joists, which are super cool, is they're trimmed down to be as efficient as possible. So that web, it's OSB kind of material, right, is only taking the shear, and then the top and bottom are only taking the bending. So the area is really only living where it needs to be the most efficient. So basically, you can lose a lot more of the center of the web because it is not doing as much as it is in the 2x12.
That is a very good explanation. So I think that even answers the other question below that. How is it possible that an I-joist is better than conventional 2x12? If I'm hearing you correctly, basically it's just because there's no defect to it, and the parts are all engineered together. And it's manufactured more uniformly than every tree is different. Whereas an I-joist, they're coming 60-foot lengths and chopped down. They're basically identical then.
Yeah, exactly.
They're way different. I love the manufactured stuff. We had done an episode on OSB versus plywood. Obviously, plywood is still a manufactured product, but in the same sense, OSB is less stiff on average, but generally the stiffness of each panel is exactly the same. I much prefer OSB in many cases because it is completely uniform, because it is made out of these little shavings and is just so averaged out. Well, if you have a piece of plywood, again, you have a couple knots overlapping, you can get a bum piece of plywood that's just junky because of overlap. It doesn't happen that often, but it's kind of the same deal. Tons of consistency in the OSB versus, maybe the plywood is a better product in a lot of cases, but you don't have that perfect consistency.
Yeah, okay. Because that's a question I've gotten a fair number of times in the last month, is people are shocked that we're using OSB 1, and for us, plywood doesn't hold up as well in these wet Pacific Northwest. It just, that's where we've had delamination, and we've never had an issue with OSB, except for the stuff way back in the 80s that was brand new. But I'd say in the last 20 years, really 30 years, it's just held up so well so that's interesting. That's good. Somebody else had a question. Oh, this is a good one on finger joints. Finger jointed 2x6s, theoretically they're straighter. Is there any penalty to those when you're calculating lateral or shear forces?
Yeah, so I'm trying to think of, so the finger jointing I typically see are in glue lams, right, where they're laminating the length together. Are you saying that in a glue lam or that in like a vertical?
In a stud. Yeah.
In a stud. Okay.
Yeah.
I would say I don't know if I've ever seen it in a stud. I know I've talked with the American Wood Council about it on glue lams because I was doing adding some capacity to some existing glue lams, and there was questions about how to field splice the new laminations that we're adding. And they said that the finger joint is designed in such a manner that it's supposed to be stiffer and stronger than the material itself because you have the glue and the epoxy. So depending on how it's being loaded, if it's being loaded in tension, I would say it's going to be stiffer than the wood. If it's being loaded in bending, it may be kind of close. You kind of create a very hard area for stress to concentrate on. But I couldn't imagine that it would be drastically less strong.
Yeah. Okay.
All connections, whether you're looking at a weld, the weld metal is stronger than the base metal. Any sort of glue or epoxy product, it's always stronger. And it might fail in different ways, but the actual bonding is generally, made sure to be stronger than the product.
Okay, so I had a guy ask me the question the other day. So typically, like in our garage portal walls, we're using like the anchor mate, so we're not wet setting, but we're cast in place. Like the stab bolts, the little curly Q, the SSTB bolts from Strong Tie.
Yep.
And in Las Vegas at the Builder Show, talking to the engineer at Strong Tie at the booth, they've got this pre-made now garage portal system where essentially it ships as a kit, you bolt it together, and they have us drilling and epoxying instead of cast in place anchors. And I forget what he called it, where he talked about the stress on that anchor forms a cone in the concrete.
The breakout?
Yeah. So is it like it would be easier for me, as long as I didn't have a special inspection, to always drill an epoxy after the fact, because we could set everything perfectly, but we're technically required to get the special inspection, blow out, the holes. And so the guy asked me basically which is stronger, cast in place or the epoxy, and, threaded rod or whatever it might be.
It is, okay, so the breakout cone of a cast-in-place anchor is way bigger than an epoxy. The way an epoxy rod breaks out of concrete is much more vertical. It is a failure right outside of the epoxy zone. So it breaks. I'm going to draw a little photo. Zach, why don't you answer? I'll draw this.
I know. I wish that there was a way for all of us, instead of this rather interesting setup that we've got going.
Oh, yeah.
I know. Yeah.
I looked at trying to do a Zoom webinar and invite people, but I'm not paying the extra $40 a month just for, a hobby.
Oh yeah, absolutely. Yeah, I think what Max is trying to say is
all right, let's see if I can do this. This is the breakout. Okay, there's a thin one and there's a big one. The breakout of the epoxy is going to be super thin and it's grabbing way less concrete. The breakout of the cast in place one, you probably have, like a headed stud or something down there, and the breakout cone is basically 45 degrees. So the area of concrete that needs to shear to yank out of there is a lot higher. The steel is probably the same, so you're most likely going to get a higher breakout from the cast in place. Unless your wall is really thin and your breakout cone gets smaller in that case, or you have like a lot of edge effects from, say you're in an 8-inch wall or something. But yeah, cast in place, probably stronger.
Okay, interesting. Yeah, I watched the video on their YouTube channel, and the installation's really easy. Site-built portal walls, they're not real super time-consuming, but like if there's a new guy on the job site, he needs to do it with you repetitively until he's got the whole process down, because there's a lot of pieces to it. The double or triple sill, the 3-inch on center nailing everywhere, et cetera, et cetera. Where the block can be if the shear panels, fit in the middle. So we've learned a lot of that stuff, though. I think most of us as framers, we learn when we do something wrong, and then the inspector or the engineer is like, you're not supposed to do it that way. And it's like, oh, okay, I'll file that away.
We learn the same way.
Nice. That's good, because whether you're an engineer or a framer, or you're the concrete guy or you're the plumber, we're basically all just the same.
Yeah.
You guys just have more liability. That's all.
Makes us feel good.
Yeah.
Let's see. I'm going to try to... Ooh, John Steen Woodworking has a good question. Ironically, he's a Finnish carpenter, but it's still a good question. Is there any information on the longevity of adhesives in engineered wood? He says, because we know how wood ages, But now what about like yeah, that's a good question. So a glue lamp made in 1950, do we ever have to worry about or whatever the first years they were making them, do we have to worry about the adhesives?
I have never gone into an old building and saw any issues with adhesives. Usually it's some sort of horizontal checking in the glue lamp that, it's kind of happens a little bit, but I don't know of any failures from adhesives from then. The only one that I've ever seen that was an issue is with they're making wood trusses for roofs, and instead of doing the gang nails where they do the plates, they were cutting grooves, almost doing a finger groove or finger joint where the diagonal truss came into the flat bottom cord, and they just kind of slipped in like that, and they glued it. And those had failures quite a bit, and actually in Oregon. And I believe those were from the 80s. But with glue lamps specifically, I don't know of any issues. I guess the only thing I've ever heard of is during a fire event, the adhesives create really toxic fumes or continue to light the glue lamp on fire rather than it trying to char itself.
Ah, interesting.
So that's a problem with older adhesives. Newer adhesives are designed not to do that, though.
Interesting.
The things that I know of that break down adhesives is often UV, right? Like same typical thing that breaks down anything plasticky. But usually that's not a problem. So that's why we have like different built up wood products that can go outside and some that can't, like that take moisture. And the other thing is, when the wood swells just naturally with humidity in the air, the glue has to be able to go along for the ride and be strain compatible. But, as the wood dries over time, that glue should be able to follow along anyway. So there shouldn't be a problem, but I've never heard of anything. That's a really good question. I kind of want to dig into it a little more.
Yeah, that's an outstanding question. So in the case of a fire, because I've heard that like big timber frame structures, if you get to them quick enough, then when that wood chars, it'll still be structurally sound after the fact.
So there's a very famous photo where they did fire testing with a wide flange or an eye-shaped steel beam and a glue lamp. They put them next to each other. They lit a fire underneath them, and the steel, as it gets hotter, will start warping a little bit. It doesn't have to become molten to fail. It just has to get to a certain temperature, and then it'll kind of twist and fall. Now with a glue lamp, wood does this really cool thing where it chars and it insulates itself. As long as the fire is not, you have to burn out whatever's burning, and then it's good. But if there's continuous fuel, you have to burn out the fuel, I guess is what I'm saying. If there's continuous fuel, it'll just keep burning. But it's like a fire. So you put a log in a fire. If you don't have enough fuel or smaller pieces to keep it hot and burning, your fire will go out and that wood is still there. And it's got a piece of, it's charred around it. So wood does something really cool where it insulates itself, and you nailed it. It's in mass timber. A 2x will burn fairly well compared to maybe a 12x12 or, a larger timber.
We will often make the member big enough to have the fire rating in the member. You can wrap the member. If you don't need to see the wood, we can wrap it in gypsum, and that's our fire rating. But we can just go ahead and make that member an inch bigger on each side, or won't be an inch, but something like that. And that way the fire rating is built into the system. So yeah, the strength is totally adequate after a burn.
Are you guys familiar with Advanced Repair Technology FlexTech Structural Compression Epoxy?
Whoa.
Okay, good. It wasn't just me.
I don't think
so. Let me look at the label. Hold on. What was this called? Advanced?
It says ART Advanced Repair Technology FlexTech Structural Compression Epoxy. Yeah, right. Say that 20 times fast.
Yeah.
While you're looking that up,
No idea.
Scott's got a great question on lifespan of concrete.
Is he asking just in general, or does he have a specific question about lifespan of concrete?
He says lifespan of concrete for structures are how many years? We recently visited the something tower in Toronto, 1,800 feet in height, and he was just thinking about it. Yeah, because like a bridge has a lifespan. Is there a general lifespan to concrete itself? Like the foundation of the house I'm in, we poured that in 2002. How long is it going to last?
Yeah, so it's really dependent on how much exposure it has to the weather and what weather is being exposed to. There's also some chemical degradation that can happen as well, depending on where you're at. We see this a lot of manufacturing plants where the chemicals they use will eat away at the concrete. There's certain types of elements in soil as well that will eat away on concrete. So when you're looking at your geotech report, you'll make sure that those aren't in there. I cannot remember the name off the top of my head. We'll have to see if Max can remember. But I would say if it's an indoor application of concrete in a typical, high rise or commercial office building, it's got a very long lifespan. I don't know exactly how long. The idea with the International Building Code is that our typical structures are designed for more or less a 50-year life cycle. We go well beyond them with our infrastructure and our buildings, but the idea is for 50 years, this should be good for any seismic event, wind event, and then the lifespan of the materials themselves for the application. So if it's a higher corrosive area, we'll do some different things with concrete mixes. We'll also do different things with rebar, with coatings. You'll see in coastal regions as well as bridges, you'll see the epoxy coated rebar that's green. There's some purple as well. And then we'll do the same with our steel if it's in a high corrosive area. So it's really dependent on what that concrete's next to, I would say.
Okay, interesting. Yeah, that's good to know. So like the lifespan on, what is it, the Big Hoover Dam? The thing I always hear is that there's still heat being generated from that concrete curing. Is that true?
Oh, yeah. It can take quite a long time. Concrete cures more or less infinitely. So it gets up to a cure, in like 28 to 56 days, and then it just slowly keeps curing and getting stronger with time. So that's kind of one of the cool things with concrete.
Interesting. Yeah. We had two projects that, in fact, it's the post today that I tagged you guys for the story, where we had to do the whole basement level was poured full height and then 2 stories above. Again, there was just no way for the engineer to trace all the lateral loads down. So it was a real hassle, but we did it. And he specified 3,000 PSI concrete, which triggered a special inspection in the city of Bremerton. So we had to have a special inspector there. He takes the samples. And the mix that we were using, I think they did a 7-day, a 14-day, and then a 28-day. They did 3 samples, if I'm getting that right. And at day 7, it tested at like 4,100 PSI. And so we all felt really good, like, okay, 20 years from now, it's going to be plenty strong.
Oh yeah, that's something the concrete plant almost always does. They don't want to send out concrete that's going to break lower, so they almost always provide stronger concrete. So what I guess strength of concrete do you usually pour?
It's that mix. So a lot of times we pour with a line pump, and it's a 6-sack 60-40 mix. So the aggregate's pretty small and it flows through that 2-inch line really well. A lot of people always pick on me on Instagram for saying I'm pouring water, and it's like, no, it's the mix. And we've had it tested twice, and they're always like, don't worry about this mix. I think 2,500 PSI is the code requirement under the International Residential Code, I think. Okay. And then, we're testing basically over 4,000 the way it comes out from the batch plant.
Yeah, I would say with commercial foundations, we're typically at a minimum of 4,000. It also depends where you are in the country with freeze and thaw cycles, what the International Building Code's limitations are on that. And that has definitely been something over the years that the American Concrete Institute has kind of changed with time, is what strength of concrete do you have with how much freeze and thaw cycles it sees. Yeah, it's always interesting to learn those things.
Yeah, interesting. So you guys, like in Colorado, you're dealing with a lot more expansive soils and things. Here where we're at, our frost line's 12 inches. So, and the soil almost never really freezes, like maybe twice a year.
Yeah, we're dealing with typically 30 inches. And then we have our expansive soils, which just wants to make everything move all the time. So it definitely becomes pretty tricky detailing foundation systems.
Interesting. That's awesome. Okay, here's a good question. Are there any rules of thumb that actually work? And I'm guessing that's like, you don't necessarily, you just know, okay, here's what I'm dealing with. This is going to work. Or do you have to calc out everything?
Max? I'll take a hit. Max, you can take that next. I would let's say for a wood structure, I would say that when you start as an engineer, you should be calculating everything. The code definitely has some minimum requirements for nailing of certain elements. But you should be running calculations for everything. Typically your double top plate splice, that's typically a more of a typical detail that you're not calculating every single time. And you get really more efficient as that's the whole idea is as you're getting more experience, you move up in the firm, your billable rate moves up and stuff, but it's because you're more efficient with your time. There's definitely things that we state by inspection that will work. I wouldn't say it's a lot, and I'm not sure with residential how much that's used versus in commercial how much we're using that. But there's always something that you've calced 50 times and you're like, well, by inspection, I know that will work.
Mm-hmm.
Yeah, I can't think of anything specific, but some little things that are coming to mind is kind of what Zach was saying, like these repeated counts that you just don't run anymore. Like, I'm not going to check if the 8-foot 2x6 wall is good for out-of-plane wind loading. It just is, unless this structure is getting put somewhere super wacky. Same thing maybe with some small headers. Like, I probably won't go through the effort of a window header on a non-load bearing side of the, there's no truss above it or anything. It's not going to be anything. But there are the rules of thumb that I can think of are like span to depth of beams. And I don't even have any of those really memorized. I've heard of many times, like inches divided by 2 is in your feet is to the inches of the beam. But those we always run. Like, that's a very critical number. Maybe in your head, where to start. Whatever the span is, it's just built in. And you're like, all right, this is going to be at least a 6-inch. But yeah, for just a regular old rule of thumb, I can't think of anything good.
I was taught the one rule of thumb for a header that only has a roof load above it, that whatever the depth of the beam is, so if it's 4x8, that's the length that we could go. So, 7.5 feet. I have no idea if that's true. So we could, and it was 4x. So a 4x8 beam, we could span 8 foot in round numbers. But I remember asking the question, like, can we really go 8 feet or can we only go 7.25 feet? I mean, do we go by the nominal or do we go by the actual?
That could get confusing pretty quick.
I know. Yeah. Okay, here's a question. Common sense tells me that a 2-inch on-center shear wall is overkill. After all those nails go into the stud, how could it have any strength left in it? And we hear that a lot. Like, you're just nailing the daylights out of that stud. You've just killed it.
Max, do you know this answer?
No, I don't know this answer.
Okay,
I believe you. It does look. It is. These are all tested assemblies. It blows my mind that that holds together. We are told it does, and we are following the rule of the law here, I guess. What do you guys say?
Yeah, my understanding is a lot of times, I'm trying to remember from code, and I'll definitely get back to you about this, but I believe when you get down to that 2-inch on center, it requires a 3x stud.
Yeah.
And so you need a wider stud to not blow it out. I've done that a few times, require a bigger stud for that, and sometimes on roof and high-loaded roof diaphragms where they're really skinny and they have a lot of load going through them, we'll do the same thing. And it's just so that it doesn't blow out.
Yeah, I'm thinking our engineer told me that as soon as we get tighter than 4-inch, we're supposed to go 3x.
Yeah, I believe that's in the code. Yeah.
Okay, yeah, and that makes sense. Less splitting. Steve Basic, architect, sent me this picture when you talked about the steel deforming when it gets heat.
Yep.
It just looks like a piece of spaghetti.
Absolutely.
That's incredible.
Yeah. And that's why when you go into big structures or most fire rated structures, you'll see all the spray foam on the steel beams, so that doesn't happen.
Okay. Yeah. Isn't that what they said about the towers that came down? Once that fire got through that's basically, yeah.
Yeah, because I think Max was just saying it only has to get to about 400 or 500 degrees for that beam to lose its capacity. Changes kind of the crystalline or the crystal structure within the steel.
Jesse Rose has a question. How, like slabs, I'm assuming like slab on grade house, how's that affected in a fire? Non-structural slab.
So they can do fine. They can be reused. There were some fires in Colorado a while back, and afterwards I went and looked at some cabins, and then I had looked at a report on how to investigate structures that have been in fires. And basically, I went around with a hammer, and there's some change to the calcium structure in the concrete. It either becomes brittle or it doesn't. And you can slam that thing with a hammer, which is what we kind of decided at the time, and it didn't kind of fracture off at all. It behaved as you would expect normal concrete to. We were saying this is just fine. It might want to crack a little bit more. It might become more brittle, but it would be perfectly fine, especially if it's not a structural slab.
Do different sidings? I remember when I first started, I had this question, like, why are we putting sheathing on the wall when we're putting lap siding on? The whole wall gets siding. But then I figured out it's only because it's top nailed, and you can still turn the wall into a parallelogram. I guess I'm not. Hey, pins 3434. If you want to be more specific in that question, unless these guys can figure it out. I guess maybe the answer is different sidings affect lateral. Like our case, we're sheathing with structural sheathing. And then if we want to do like a board and batten style, now we're going to put another sheet on the top of that and nail off the bats. Do you even account for that as a structural engineer?
No, not at all. We take our wood book that has tested values for all the different types of sheathing, and then the different nail patterns, and that's it.
Yeah. And then, as Zach said earlier, like, there's gypsum on the inside of the house, and we can account for it. Some engineers may do this. I'm not really sure. I typically haven't, and it's only about an eighth of the strength of the OSB on the outside. You can change the siding of the house, right? So it would be really relying on a lot to say, this is the value of what it is right now. We're sure it's going to be the same in 20 years. It could go to something totally different.
That makes sense. Yeah. By the way, I love the trick about just hitting the concrete with a hammer. I mean, it sounds like that's how we'll test the load-bearing column, is we'll hit it, and if it really vibrates, we're like, it must not be much of a load on it, or you kick it with your foot and it moves. You're like, okay, we can replace that without too much stress.
There was one on there, a tornado question, I think, that was, when should an engineer look at a house after a tornado event? Is it worth just doing the repairs? That's when we had done a tornado episode recently, so that was kind of on the mind for me. And thinking about, there was a tornado in Colorado a while ago, and I happened to be in a house afterwards. It had nothing to do with the tornado, but a lot of the roof trusses had failed in tension. There was some, maybe uplift force that it didn't collapse anything, but you could just see like a splintering. And if that's something you see, that would be definitely a red flag that you should have an engineer look through the house, because there's probably some other issue somewhere. And if not, you still need to figure out what the specific fix on that is.
I noticed on the APA's website, I think it was one of their webinars. Oh, I think the title of the YouTube webinar was like sheer exhilaration or something. The engineer was being very cute. And he basically, I think, was making the point that we can do our best for earthquakes and hurricanes, but tornadoes, it's kind of like all bets are off in many cases, because that's just a massive amount. Like, what was the one that was just in the southeast? Was it 2 miles across? Like, how would you...
Gosh, the load on those things is so much higher than the load we designed a normal building for. So, like, the force is proportional to the square of the wind speed. The reason I say that is, so our tornado is 250 miles an hour, and, like, depending where you are, let's say you're 115 mile an hour for your normal. So you're like 250 squared divided by 115 squared. It's 5 times stronger than you normally design for. No chance. Nothing you can do.
Is that like, really, if you were living in like Tornado Alley, if I was going to, I hit it big in the stock market and I could retire, and I retire in Tornado Alley, at that point, I'm just building a concrete house. Is really about the only thing I could do, or do I need to build underground?
Oh, you need to build underground. I mean, there's so little you can do. The provisions that make up the storm shelters, it is a fully grounded masonry wall with bar in every single cell with a concrete deck roof. It is so extreme because just the uplift force on these things. So if you wanted a house to withstand a tornado, it would be the ugliest house you have ever seen.
Interesting. So I think I'd rather live in the Pacific Northwest, and there's a 10% chance in the next 50 years we'll have the big one. Whereas every year you're like, my parents grew up in North Dakota, and I remember when we were visiting as a kid having to run to the storm shelter because there was tornadoes forecast.
Wow.
Yeah, I couldn't do that.
Oh, I was going to say, I have some interesting, I think we can talk about a little bit in seismic for the Northwest. If you want to write those down, we can start the next session. But I would say the biggest thing, is unreinforced masonry structures and masonry in general. Those are going to be the ones that you more than likely don't want to be in during a big event. Houses traditionally have that kind of extra capacity Max and I were talking about. California has a big issue with soft stories, big retrofitting, construction events going on down there with those. That's not the typical building in the Northwest or house. And so that's not as big of an issue. So when that big event comes, houses are going to see a lot of cracking of the gypsum on the inside. If they have masonry on there, masonry as a industry, we haven't done a very good job at attaching masonry to a building. We just saw this up in Alaska, their recent big earthquake in the last year or so. A lot of masonry fell off of buildings. And the issue with that is not necessarily hitting people, but it's blocking exit ways to get out of the building. Has been the big one. So I would say if you're in your home during an event, it's not going to be the worst place to be. You should still get under your table, but try to stay away from masonry, like, brick masonry. Max just had an earthquake. I think it was a 4.7, 4.6, 5.7. 5.7.
And yeah, the only failures that we saw were masonry. I mean, you think the force of the earthquake is proportional to the weight of the building. So you throw a bunch of brick on the outside of a stud, a normal stick frame house, that's going to be way worse than just a normal stick frame. Like, I'm in a 130-year-old junk stick frame house, but I'm not worried because it's like the old, what was it, the old diagonal latch sheathing?
Oh, yeah. Like the shiplap?
And then someone put like this junky siding, and it's not a system that I could give a number to, but I am sure it's not going anywhere.
Interesting. Yeah, that's good to know, because like in my house, our master bedroom's on the front of the house, and it's a gable roof, and then we overframed on top of it. And so we had fully sheathed the roof, and so I always tell my wife, I'm like, in an earthquake, we don't have a story above us. We have that roof, which is attached from the upper roof and then they're fully sheathed walls. And I was like, I think we're pretty good where we're at. It could just be the light comes down.
Yeah.
So we'll just sleep with hard hats on. Which
yeah,
that's not going to work.
On the fault as well. So.
Okay.
Yeah.
Let's see. Before I lose these questions, and if there's anything you guys want to, because the other thing I can do is I can just kick us out and restart it too.
There you have it for part 1. Hope you enjoyed. If you have a chance, go talk to your local contractor or GC. You will learn a lot.